So dear students, that we have to again compile some of the things regarding the sign convention. Already we see for a mirror, now we have to see for the lens. Here for a numericals, if we just going to be combined, here we just make a simple tabular form. Suppose we have a convex lens. Then object distance, so it's very important part, u always negative. Image distance, v positive, but in exception case, already we know that the exception case means when object between F1 and pole, then image distance V is negative. For focal length, it's a positive. So object distance negative, image distance positive. Only in case of the exception it will be negative. Exception already we know that when our object between the F1 and pole and focal length, it's remain the positive. This is for a convex lens. Similarly for concave lens, object distance negative, image distance it remain the negative, and focal length is also negative. So when we are going to be solve the numericals, then we have to keep in our mind how to correlate all the values. We just going to take a simple example. Let's see. Suppose, consider object distance 10 centimeter. It's very similar example already we seen yesterday, that focal length 5 centimeter. Find out the image distance. Yesterday we see in case of the mirror. Now the same sum we are going to be consider in case of the convex lens. So if we are going to be say that it's a convex lens, then for given we have to justify. First of all, object distance means u. For convex lens we have to keep that u is minus 10 centimeter. So here u is minus 10 centimeter. Focal length f, guys, f is positive, that's why it's a 5 centimeter. Image distance v, we have to find. Here due to the lens we are going to use the lens maker formula. So lens maker formula, I hope you know very well. 1 upon f is equal to 1 upon v minus 1 upon u. Let's put the value 1 upon 5, 1 upon v minus 1 upon minus 10. So here what happened, that 1 upon 5 is equal to 1 upon v. It's going to be 1 upon 10 plus minus minus plus. So if we put the value like this, so 1 upon v, 1 upon 5 minus 1 upon 10. So here 10 minus 5 upon 50. So it's a 5 upon 50. So 1 upon v. Here both are cancelled. 1 upon 10. So v is equal to plus 10 centimeter. As we already know that this v is plus 10 centimeter. It means what? In convex lens we already know that object distance in minus, focal length in plus, then definitely our image is in plus. Got it? So in this manner we can solve the numericals. Clear? So keep in your mind, similarly if they ask for magnifications, then we can go for the magnifications. I just going to be rectifying it here. For magnifications, we can put value m is equal to hi upon ho and v upon u. Here we know very well m is equal to value of v is 10 and the value of u is minus 10. So m is equal to minus. So magnification is in minus. Why it is in minus? Because here we have a inverted image. Inverted image. But image have a same size. That's why n is equal to minus 1. So in this manner we can solve the numericals. So this is the last part of this chapter. But one more thing we just want to include in this chapter. It's called the power of lens. Actually power of lens, it's a part of next chapter. But once we discuss about this lens, then definitely we are going to include the power of lens. Very shortly, I just want to explain. Power of lens see, power of lens. If we just consider this power, and if we consider this power, just see the thickness of the lens and this thickness of the lens. Here, when light rays incident due to the higher thickness, light will bend very near like this. And this point is known as the f2. So this is our focal length. This is our focal length. Yes or no? When we just consider this case, so in this case, here rays will come like this. They all are concentrate like here. Because here the thickness of lens is thin. Due to that reason, it will be concentrated very far. So here focal length is high in case of, this is called a case 1 and this is the case 2. So this two things is going to be calculate it. If power of lens is high, then focal length is less. Power of lens is small, then focal length is high. So here both things is going to be calculated like that. Power of lens P is inversely proportional to the focal length. Sorry, P is inversely proportional to the focal length. Again, if power high, then focal length short. If power low, then focal length high. So power is inversely proportional to the focal length. So P is equal to 1 upon F. The unit of power, P is equal to 1 upon F. So we can say that if our focal length is in meter, then 1 upon meter, so it is the meter inverse, or the unit of power is diopter. It's going to be denoted by D, capital D. This thing about the power. So now guys, you have to do the practice about practice of the numericals on the basis of power, on the basis of lenses, and on the basis of refractive index and mirror. If you have any doubts, then you can ask me. Okay, thank you.